And this time in the workshop is an AIWA AD-FF90 cassette deck. It's a lovely bit of kit. These were released in 1982, very stylish they were at the time, lots of buttons. I wonder if they work. This one has a pure amorphous alloy head, which I think was very special back in 1982. But what do I know, I was only 5. And it's also got Dolby HX Pro, which means it comes with a load of buttons for selecting different modes. I'm not sure these feel too clever though. Oh dear. CompuBrain, a microcontroller in it for added trouble. And not too much going on around the back, which is a good thing. It's a tape deck. It's got stereo mic input and you got line in, record and line out and playback. All you need. Oh, what's this? MPX filter. Well, this is definitely a Japanese market model. 100 volt AC. Good job I got a Variac. I'll wind this down to 100 volts. There we go. Just got to deal with this funny plug now. So luckily crop clips work out here. Just cover them up a bit and keep them out of the way. That's a rather nice vacuum fluorescent display there, and it's not dim at all. That's very good news. Let's get a look inside. We can just about see the tape head there if you move the door in and out. Hopefully it's in good working order. I'll hate to have to replace that. We'll try taping there. Oh. Well, for some reason the door won't shut with the tape in. What is wrong? I don't see anything wrong. Just looking at the pinch rollers and the capstans, they're not engaged with each other. Now that would be a sign that the mechanism's sort of stuck in play position. But yeah, not sure. But it looks like mechanical issues. At least that's the start of it. You know how these tape players go. Oh! I don't know whether to be impressed or disgusted, to be honest. Wow. Like someone ate a bowl of wires and then puked them up. And there's a lot of silicon in this. I'm not surprised really. Computers back in 1982 had a lot of chips. Even got their own AIWA branded ones. And more AIWA branded ones down here. And another one here, which is an NEC chip. This is bound to be another microcontroller. Then we've got a Dolby branded chip there. And another 2 here. This was clearly a high-end machine at the time. Wow. The tape mechanism looks fairly conventional for the time. Twin motor design. This one's a servo one, I think. Keeps track of the speed. Let's turn it back on. And I'll straight away notice here just no action. I suspect that these motors should be running. These aren't. Totally stationary. Let's measure what's going on with the motor. Oh, 1.1 volts. Let's have a look at this mechanism, see if it takes a tape, or why it won't. Oh, it does now. So will it play? No. There's nothing happening. Nothing at all. I'm a little bit suspicious of this motor because even with 1 volt going on it should probably turn a little bit, or at least I should feel something. But it does feel very almost seized up to me. I suspect there's mechanical trouble. Just fishing around these wires, this brown wire can be traced down to this plug here. So I'm just going to pull that out so I don't blow a circuit up. I'm just going to put 12 volts on, straight onto the motor. Let's give it 12 volts and a good dose of current, maybe an amp or so. Let's try that. Oh dear, no movement at all. That motor's got to come out. I think this is going to be a right pain to get out, and I've just remembered, I hate tape decks. First place to start is normally take the cover off, which can be a challenge. Oh, not in this case. I'm just going to start pulling screws out of this. Will it come off? Oh yes. I've certainly loosened everything. Will this come out? Oh, maybe. It's out. Yes. It's probably fair to say the belts are a bit stretched, I mean, as they've just fell off during the process of taking the tape deck out. A few more plugs to undo. And this big long one. Luckily they're all different sizes, so I can't get it too wrong. Of course there's quite a lot of wiring to these heads and the erase head there, yeah. I had to trace these wires too. One lurking down there. And the others are just here. It's certainly well made, look at that. There's not a lot of plastic on this. The audio files are going nuts for this bit, but the problem's around here. And there's just 3 screws to get this back frame off. Oh, okay, 4 screws. I hadn't looked. And we're off. Wow. Oh, and this is C solid. Wow. Okay, we found the problem. Just slacken these rubber mounts off. Hopefully it just twists. Or if the rubber's not knackered. We'll just do them all the way. Just going to unsolder these wires. Well, it's 41 years old almost to the day, look at that. And this is pretty seized. Oh, it's loosened off. Oh, and then seized up again. Oh, no, it's loose. It's tight. Oh god, something drastically gone wrong here. I'm going to have to pull this motor apart to see if I can fix it, and this pulley might have to come off. So it's best to check the heights of that before I go any further. So from the bottom of the pulley to there is just shy of 4mm. I don't know if it matters. I'm going to put a little mark on there just so we keep alignment. A little bit of levering here. Hope it pops off. Oh, we're lucky. We're lucky. Okay. I'm not sure which is the windings on here, so I'm just going to unsolder a few places. I'm not sure that's helped. I'm going to pull this pulley off. If it'll come off. Oh, it will come off. See what that does for us. It's still not coming off. I'm not quite sure why. I've undone the 2 connections to the actual motor itself. This little servo board is stuck. It feels to be pivoting around here. And if I didn't know better, I think this transistor's actually stuck. Is it? Yeah, look at that. I'll just keep unsoldering stuff. That's got it. Well, that transistor appears to be glued on. Yeah, I don't think it's melted on. Well, it might have melted on. Well, either way, it's stuck on there now. And this board doesn't look too clever either. Yeah, that inductor here has had a fair bit of heat stress. Look at that. Probably not too bad though. Hopefully it's not too damaged. But I bet that transistor's knackered. Just going to put some proof marks on here as well, just in case it matters. If I can get the pliers in this slot, see if I can straighten these little tangs out. Looks like I have. And it's away, look at that. Oh no. This isn't a good sign. The windings are all different colours. Yeah, this is seized up. I wonder what caused it to seize though. That's interesting. Whatever it's seized up has made it a bit burnt out. Let's measure from one segment to the next. 3.8 ohms. Okay, round here. 2.9. Okay. About these two. Nearly 6 ohms there. Wonder about this transistor. Oh! Amazingly, it's okay. I've got to be honest, this is quite a serious problem, and there's only one way to fix that. Unless I've got a time machine and can go back 40 years to buy a new one, I've got to rewind it. This is not the most complicated of motors to repair. The 3 windings are quite separate, and the windings of the wires are just joined on this disc. The real question is, are the windings all gummed up with some sort of resin or varnish, or will this unwind neatly? Because I've got to count the number of turns on here. And luckily I've got just the gadget to do that with. I've had to modify this and put a 4-jaw chuck on there, which was quite cheap on eBay. Made in China. Perfect what I need. Just having a look under the microscope at this, you can just see how the windings are formed on there. And they look a little bit loose, to be honest. I'm hopeful this can come apart easily. First things to do, this is the burnt winding as you can see, is undo these little solder connections there. Just going to get the tweezers in there. Try and get them just underneath the wire if I can. I wonder if this is wrapped around something. This is the old trick they do. There we go, we're off. I think it'll be an advantage if I can take this disc off completely and disconnect all the wires, because this will be in the way for the rewinding process, and as it's lifted off so nicely, I'm going to fetch it off. Yes. I think I need a solder sucker to get this solder out. There's one. So now it's ready for unwinding. Just going to clamp between these two jaws into where this wedge is. Just nip that up and try and get it to sort of sit centrally between them. See how that lines up. That's pretty good. The only problem I've got is the way this is wound, the number's going to count down backwards, so I'm going to have to be mindful and just keep my eye on that. So we'll reset it and we're going to gently go for it. There's a little bit of stickiness in this. I don't want to break the wire. This could be a slow job, I think. What I found I need to do is melt the lacquer on this. Bit of butanone or methyl ethyl ketone, and just feed some onto there, just a few drops. That soaks into the windings and loosens it all up, because there's a lot of glue on here. Let's find a loose end again and continue winding. So, 578 turns. That turned out to take quite a long time, about an hour in total. Luckily I've edited it for you. But it turns out the solvents need quite a bit of time to soak in and soften it all up. And I'm not going to count the turns on the next ones. I think I'm just going to sort of hack them off. See how I get on. I think this is taking a bit too long, so I'm just going to start hacking it like I said I was going to. The bottom layers are stuck in the glue, so I need to put some more solvents on there. See if we can soften that up. We'll have this off in a few minutes. Should be able to get under it now. Well, now the coil's off, just having a look around. It doesn't look too damaged. I think we can work with this. We'll check the commutator for damage to make sure I've got continuity from there to there. Yes I have, but not to the shaft or here. Good. Also from the one to the next one. No problems there. Good. In fact, I'll rotate this. Excellent. Load it back in the chuck. Nicely aligned. I need to check how thick this wire was. It's pretty thin, but I need to measure it. It also feels a little bit rough because it's had all sorts of gunk on there and it's been sticking together. So the reading's going to be a bit higher than it should be, I reckon. Let's see what it is. That's measuring 0.13mm, and that's pretty close to this 40 gauge wire I've got here. Let's just measure how that works out. About 0.135mm. I'd say that's pretty much the same. Just load it onto the machine, put that little bobbin on there. Okay. I'd like to put a bit of insulation around the core of this so it doesn't sort of chafe the wire. By the end of the wire, there it is. Pass it underneath there. I'm just going to wrap it around here, just as a bit of a way of anchoring it whilst I start the wind. Well, that's the lot. So if I can get this wire, I'm just going to wrap it around this lug if I can. So check the resistance of the windings, check they're all balanced. That's good. Perfect. And over here. That's great. I'm also going to check we haven't got a short to the armature. And we haven't. Now I've got to solder on this little disc. It's actually a ring barista used to snuff out any high voltage spikes which would cause damage to the brushes. Pop it on there, just line the little pads up. There's a black mark on there, that's perfect. So I just need to make that stay on there whilst I solder it. Put this bit of blue tack, well it's not blue tack, it's white, whatever that is. I think it's Pritt Stick's version of it. Anyway, it does just a fine job there. Just check that this is lined up with the original solder points. Yeah, that's good. And so is that. Just check it's running concentrically. Yeah, it's pretty good. As I can tell, that's pretty good now. and it's going to be spinning around like that. So I'm going to put a little bit of lacquer on these windings just to firm them up a bit. I'm going to use this electrically insulating varnish. I think it's a polyurethane type thing. It doesn't say. Just going to brush some on. I think that'll do. I could really do this transistor coming off here. I'll see if it can be yanked off. Perfect. Now I've got the servo drive board to deal with whilst we're waiting for that varnish to dry. I'm going to try and put that transistor back in now I've got it off. There we are. Looks a lot neater now. Just going to solder these legs back in. I've already checked this transistor to be okay, so there's the base. We've got a good junction there and there. Yeah, perfect. I'll check around a few other bits. There's some diodes down there. There's one there. Yeah, that's fine. And another one here. Oh, that's not fine. Since I found some shorted silicon, I need to check some resistors, although they don't look burnt. Got 2K7 there, that's bob on. Then we've got a strange value here, this little one. What's that? 6K2? That looks a convincing reading anyway. Over here we've got 27 ohms. Yeah, perfect. What's this up here? Oh dear. 82K. Yeah, 4.8K. That's not what I expected, but it could be right in circuit. Then finally we've got this one. What is this? 5-band resistor. Grey, is that red or orange? Oh, and a black. 883. Yeah, 883 ohms. And it's measuring 51K. That's not good. With this sort of damage on there, I need to work out what's going on. So I've decided to have a little bit of a sketch of the circuit board and find out what's going on. I've come up with a little schematic. To do this, I've just drawn out where the components go and given them all names, just labelled them up, and I'll turn that into a proper schematic. And here we go. This motor control trip is made by Panasonic, I think, or Matsushita, but I can't find any information about it whatsoever. And this is the circuit and how it's wired up. So we already know that this transistor was getting hot because it was melted into the casing. And we've also seen this diode is short. And the other thing we found is this one, which is a fusible resistor, I think, as open circuit. This is overheated as well, so it looks like current has flown through the transistor down to the base. From here it's gone straight to the shorted transistor. We also had the windings burnt out, so some it's gone. I don't know what went first, but yeah, hopefully this chip's okay, because I'm not sure how easily I can get them. Another mystery, well, we've got these two resistors in series. This one obviously is fusible, and we've got 27 ohms plus 883, I guess. That adds up to be 910 ohms, which would be a standard. I just really don't know why they've gone with this value. That is so strange. The thing with fusible resistors is they're normally rated for something like 1 watt, and at that sort of power the temperature rises in here and that blows the elements. So it's a thermal thing. The problem I've got though is 883 ohms. The sort of current to make 1 watt is about 33 milliamps. That's really tiny. I don't think I can get this at all, and I don't know if I can get a 30 milliamp fuse. So I'm afraid this is going to have to put a standard pair of resistors in. Well, not that and that, that and that. Let's desolder the offending parts then. Hopefully I've unsoldered the right bits. I think I have, that's all loose and wobbly. And whilst I'm desoldering things, I might as well take these caps out because I don't want any comments off the capacitor police, do I? So I'm going to measure this 4.7 microfarad cap. 4.95 microfarads. It's not far off, but it's a bit high, which makes me think it might be a little bit leaky. Now let's see what's happening with the 0.22 microfarad cap. It's rather a small cap for an electrolytic, I have to be honest. 0.9 microfarads. Yeah, that's very suspicious. These are probably past their best. Now to stuff in the new components. We'll start with this resistor here. I'm actually installing an 820 ohm, not 883, because I can't get one. But to compensate, the 27 ohm resistor is changing to 100 ohms. Now these particular two I've already measured, and they come up with 911 ohms, which is very close. I couldn't find any information about the diode that shorted, but it looked like a small signal diode, and it only had the letter H on it, which I don't think means anything. But I'm going with a 1N4148 because I think it's probably beefy enough for what this is doing. I've managed to find a 0.22 mic cap in the box. Very happy about that. So straight swap, and it fits nicely. And same with the 4.7 mic cap, readily available. Snip those leads off now. Because I haven't got a fusible resistor in here, I've left this stood off the board so it doesn't burn it in the event of a big overload. This gives it some chance of being repaired again. This should be ready now as well. I'm really pleased how this has turned out. It looks nice and it feels good, nice and solid. The varnish has done its job. So I'm going to put it back in its housing, but first I'm just going to lubricate that bush. There's a little bit of oil in there. So I've got the motor end cap here, and there's the brushes inside. They're sort of spring brushes and they need to be pulled apart so they don't get mashed up when I put the shaft in. I found you can just poke some tweezers in and that should separate them nicely. So the painstaking part of just sliding that in there. That should be good. Well, that looks lined up nicely and it turns freely. That's actually a good thing. Just going to squeeze these two little tangs back up, stop it falling apart. A bit difficult to get at, but just a little squeeze with the pliers. That should do it really. Okay. I have just noticed this little arrow where the transistor used to be melted on. There's an arrow pointing to the direction of rotation. I guess we should check that because I don't know which polarity these are. So I'm just going to put a bit of power in there. Maybe just a few volts, don't want to burn it out. That'll do. I'll try negative on this one. Put the positive lead over here. Turn it on. Not sure which way it's going. Just see through a little gap there. I can feel, yes. Yep, that's correct. Mark that little plus. Okay. According to my diagram, the motor positive terminal is in this corner here, or there. So, I'm just going to connect it like this. Luckily it fits as well. Just going to solder that on, just need something to balance this on. This will do. Connect the power supplies on, see how it runs. Well, I can hear it whirring. See if there's any speed adjustment. Oh no, None at all. Oh, this is a bad sign. Pick up the ground there. This is the motor output. That's 11.1 volts. That's pretty much flat out. This is the gate drive or base drive to that transistor, 11.2. Yeah, that's calling the transistor to be turned on. That's why. What else can I see? We've got pin 3 is a reference voltage. Bang on 1 volt. I reckon that's okay. Pin 2 is the other side, that's the negative part, so we've got 10 millivolts there. And this is the reference 0.3 volts, yes. I wonder what's wrong. It measures believably. Just looking back at the diagram I made with a lot of assumptions about this chip, I have noticed something just. I've got a resistor here and here in series, which I said was weird in the first place, with weird values. But of course this current is going to come from the positive supply through the base, straight through here, and just back through this circuit. So no wonder this transistor's on. Maybe I'm wrong about this resistor. Maybe it's not a resistor. It could be a capacitor. It's still strange colour bands on there. I don't know what they mean. That'd be 103, which could be 10 nanofarads. Don't know what the grey bands are though. Well, there's no harm in measuring it. 12 nanofarads, it's about right. And that component sat right there, and I stood that off the board, and it's right on the edge. I think I can just unsolder that and just test it without the capping. Probably run okay. Pull that out. There we go. Let's put the power back on. Well, straight away that's running slower. I can hear it. That's perfect. That's working. So that confirms it. It was not a fusible resistor that had blown, it was a capacitor. I'm allowed a mistake in every video. Those are the rules. So this isn't right at all. So it's actually a capacitor. And we'll call it C4, like the explosives. And it was 10 nanofarads. Well, that's completely desoldered this now, because I've got to change that 27 ohm resistor back. Well, I'm getting a bit fed up of seeing this board, I have to admit. Let's put this one back in. Well, the legs are a bit bent in an awkward position now. Same with the original capacitor. Give it another test. That's perfect. I'm happy with that. So that can now go back in its original housing. And the lid, exactly the orientation it came off on. There we go. Perfect. Just need to put the pulley on. If I remember, it's about 3.7mm from there. So I've got a 3.5mm drill, should be close enough. Just going to sort of drift it down. That should be exactly how it was when it came off. But working. The motor was fastened to this plate. If I can find the holes. There's one. Now back to the tape mechanism. Before I put the motor on, I'm going to replace these belts because they seem to be falling off. Although they don't feel bad or sticky, which is a nice change. I assume the shorter one goes underneath. Let's try and wind it on. Lovely. I'm going to hook the longer belt over the motor pulley. Let's keep some tension on it. So I think I'm going to have a bit of a struggle here. Sort of wrap it around there. Well, that's all looking very satisfying. Just retin these solder pads, are a bit mullered really. It doesn't look in too bad condition down here, though it could probably do with a bit of a clean. The rollers don't look too bad, but I'm going to change them. And that's mainly because the new pinch rollers came with the belt, so they might as well be fitted. The left side's got quite a few springs in there. I'm a little bit dubious about this, but I'm going to undo this little nut, which came off by finger force. That's unusual. Not to let these fly off. But it looks the right size. I've got to pull this pin out. I'm a little bit worried about that. I hope nothing breaks. Well, that was too easy. Hopefully this will go on without springs flying off everywhere. A little washer back on. Then the little nut. That's better. The right hand side's held in with this little clip, but you need to open the cassette door to get in it. It's going to disengage that spring to make life a bit easier. Pull that hook out of the way and lift it out. Hopefully this one goes as easily. Oh, see, this is now how I'm used to them. Yes. This course will me a little bit better than those pliers. There we go. They're the same size? Yes, they are. Oh, it doesn't want to go in. God, that's tight. That's no good. What's wrong with that? Can't get it out. Let's check the thickness of this. The original one, 7mm. Okay. And this one, oh, about 0.35, 0.4mm bigger than the other one. I just need to sand this down a bit, I think. Get in there. That's better. Poke this shaft through the hole. So just stick slightly through. Push our rubber wheel in. Just try and line it up centrally. There we go. Perfect. Just feed the spring back over there and we're ready. Just wiggle it around here, get it past that mechanism. Okay. Let's clean these heads with a bit of alcohol. Just rotating it. I can't actually see any muck coming off, so probably not that dirty in the first place. Just dusty, I think. And that one there, I think that's the erase head. Just give these capstans a wipe just in case there's any muck on them. It's awkward to get at, this is. Well, I think that's it. Ready to put back in. put a couple of screws back in. Let's plug the heads back in. Bit of a tight squeeze in here. And this one's even worse. Crikey. Might put a tape in, just on the off chance this works, and power it on. Still nothing. I only get that light blinking. What voltage are we getting on here? Oh, still 1.2 volts. More trouble. I hope this thing's worth a lot of money because it's becoming a pain in the bum. So there's more trouble in here somewhere. This has got to come apart more than it is now, so let's loosen this cover off. Actually, I want the whole back panel off, so all the screws are going to come out. Oh what? The back of that DIN socket, it's got little plastic pegs. Just got to push them. Well, this looks power supply related with a heatsink, big transistors and big capacitors. And straight away I'm seeing this. This doesn't look very clever. I don't know if these are dry joints on the bottom, but they could be. It's certainly got hot. I'm guessing that's where the 12 volts comes from. I couldn't find a manual for the AD-FF90, but I found this one and it looks very close to me. I'm wondering if this is just the European version. So this was issued in 1983. Not entirely sure where the components are located because this board layout's not very legible. But that burnt resistor's around here somewhere. I'll try and find it in the diagram. This is where the 12 volts is regulated and these components look to be connected roughly in this way. I reckon it's right. You can see the 330 ohm resistor there. It must be an early board. Those two Zener diodes are occupying one place. And if that's right, that's a 1 ohm resistor, half watt fusible. I did mention that you don't see these for sale that often, but I do have some. I'm thinking 1 ohm is very likely to be fairly normal. Although these are quarter watt, so no. Oh, half watts. Perfect. And yes, I'd agree that's 1 ohm. Brown and black, yeah. Okay, I wonder what it measures. Well, that's basically open. Let's go check this transistor's actually okay. Okay, good. Yes, no shorts there. Oh, great. Just slide that in there. I'll get the holes to line up. There we go. Resolder these. There's a few dry looking joints around here. It's going to just give them all a little touch up. I think this old insulation tape is supposed to be insulating these from the chassis, and this isn't going to do it very good anymore. So I'll have to replace this. Just get the tape underneath it all. Sort of just try to encapsulate it a bit. Just want to clean some of this muck off here, the solder flux and residue, and just make sure it's actually all okay. I think it will be. It's always worth a check. We've got a rather untidy production bodge here. This little cluster. This one's actually touching that. That can't be good. Yeah, this is another one that could do with a bit of insulation. Let's try and sneak that under there. Right, I'm going to put this back on just for a bit of structural integrity, because that board's holding all the weight up and I don't like that. Let's see if we got the 12 volts now. Well, we got 12 volts. What's that racket? Well, I hope that's not the motor. It doesn't feel like it, to be honest. Yeah, the chassis is rattling. It's speed related. There's something wobbling around the bottom of this solenoid. That shuts it up quite a bit. Yeah, some mechanical issues. Yeah. Something not engaged right. Oh, hang on, it's supposed to go that way. And it makes no noise. It's all moved into place. The motor's going backwards. I can't believe I did that. It's not too difficult to put right, but I've got to take it all out again. Just pop this lid off again, very gently. There we go. So all I've got to do is just turn this round, like that. Look, I even put a plus on there and everything. Let's pop the lid back on. Let's try it with the motor going the right way. That's better. Nice and quiet. That is damn near silent, that is. I'm very impressed. At least the motor's done. Will it play a tape? Oh, that's not great. The take-up rollers aren't moving. Why aren't the take-up rollers moving? Oh, is that me tape? Oh, bloody hell. Hopefully it just comes out. Nah, not too bad. Right then, this motor that I heard running is supposed to be driving these take-up rollers, and it's not. The mechanism is all sort of at the front, so I've got to take this cassette tape holder out. It's all sort of dowelled and riveted, so not easy to remove. There's a couple of screws, so I'm sort of fancying those. Hope they get this apart. Oh, it still won't come. Oh, it's trapped. Ah, more screws back here. Well, there's the mechanism. The take-up rails are here. There's a little brake on there, and this should be the drive reel, I think. Just going to connect some power to the motor just to drive it so we can see what's going on. Just lift the brakes off. I can see the pulley spinning, but nothing else going on. Wonder if this idler's jammed. Just need to strip some of this stuff out of the way. Take this lever off. And this little spring retainer. Hopefully it doesn't all come flying off. Just need to get the heads off now, so I think I just need to tip that up there. It's a little wiggle. Yes. And we're free, sort of. Put some power back on that. Yeah, it's just spinning. Yeah, it should be working. See if I can just flick this off. Awful little circlips they are. There we go. Oh. Why is the spring on top of there? That can't be right. That felt pad, surely, should be operating on the back of this idler. I reckon it should go on like that. If I can get it on. There we go. Then the spring goes on there, not behind it. Then my favourite part, putting the washer and the clip back on. Oh, this is always going to be a challenge. Hopefully I can just press this on with my finger. It's a tricky job. Just lift the brakes off. Oh. Still no good. I don't know if this tyre's worn. It doesn't look too bad. It's not cracked or anything. It feels nice and soft. It's not got much springy tension on there though. In fact, has it got any? Let's turn that back on. Oh, I have to lift the brake off. I keep forgetting. Look at that. Slightest bit of tension added. It's working. Pretty sure there should be a spring on this pulling it up. Yeah, I need to do a bit of digging. Knowing what these things are like for springs shooting off, I'm going to disconnect this brake. There's a spring there, waiting to fly off across the workbench. It's also a good idea to remove the heads. And this will have to come off again as well. I'm getting good at this now. And the capstans will have to come off. Pull those little retainers off. There we go. Now I can unscrew the motor, get that out of the way. That just lifts up. So here's our idler flapping around and there's no tension. And what's that there? There's a spring flapping around. What's going on? I see a little retaining clip there and this spring's just not doing anything. Yep, that's better. That's got more going on. Now the fun's going to begin. That little peg on the end there has to engage in here on the motor. Oh heck. Just very gently tease it in, keep it in position. That could be good. We'll try it now. Oh, you're kidding me. No way. Let's check this tyre out, you never know. Cheeky. I caught that though. At first glance it doesn't look too bad, but oh, look at that. It's worn really strangely. That's almost a trapezoid. Well, that can come off. Well, I found this. It's a similar size, pretty close actually, and it'll fit, and importantly the edges are straight, so I'll pop that on. Okay, see how that works. Put the washer back over it, my favourite part. Let's try that. Oh wow, still no good. It's like it's not pushing it hard enough. What's going on? There's not a lot of movement there. Let's take this plate off. So what can we see? That's the bottom of the arm. Still got the spring on it. It don't have much room, does it? Well, that's no good at all. It's as if the motor's too big. Oh, look at this. It is. It's got this magnetic shielding around it, and there's several layers here. What, 4 layers, and round here there's only 2. Just need to spin this round. Well, these wires are a bit of a problem. They might not like it. Well, that looks better. It's not banging into the motor body now. Maybe that's it. How about now? Oh, look at that. At last, things spinning in the right direction. I'm a happy boy now. Let's try the other direction. Swap these leads over. Excellent. Very happy with that. Put the capstans in. Fit the belt again, hopefully for the last time. Let's push the little retainer clips back on. Next to brake assembly, you need to put the spring on there and hold it like that. And steer these little pegs into the sockets. There we go. Before I put the head assembly, I'm just going to put a bit of new grease in there. There's a ball bearing that slides up and down to support the head. I've got some very sticky red grease, which is ideal for these sort of things. Just drop it in and it should sit still. Stuck in the grease. Excellent. The trick here is to engage this T-slot on this plastic peg here. It's a little bit awkward. Next part is this spring, which should have a ball bearing under there. But you know, I never saw one come out. Now normally I think that was me, I lost it, but given the problems I found on this, I don't think it was me. Just got to get the spring hooked over here. And then it just pulls over this little tang here. I'll put a little dab of grease on there as well. If you're going to be messing with tape decks and stuff, it pays to have spare ball bearings of various sizes. These ones are 2mm. And in it goes. Hopefully it stays there. Just line this slot up with a plastic post. There we go. And that's fairly firm as well. You don't want your amorphous head flapping around. Then we've got the brake release arm. Let's put this cassette door mechanism back together. The side plate's a little bit awkward to fit, so I need to twist that round into engagement there. Got to clear the eject button. Yes. Should probably wipe my greasy fingerprints off here. Probably no good for the tape. Well, it's all back together. See if I'm lucky, because I haven't been very lucky so far. Oh, that's new. It didn't do that before. Oh dear, I think Belinda's balls are dropped. All that motor's running slow. I will change it for something I can measure. This tape's had a bit of a battering. Should be 3 kilohertz though. Yeah, that's quite a lot though, that is. Let's find the adjustment hole in the back. There's a pot in there if I remember. That'll do. Well, that doesn't sound too bad at all. Looks good on the scope as well, pretty even. This is looking okay. Not sure why that's flashing, not sure it should be. And what's this doing? Absolutely nothing. Let's check it fast forwards as well, shouldn't I? Oh, that's great. Rewind. Yeah. Play. Pause. Unpause. Yeah. Happy with that. Not sure what this does, but it's an 80s thing, so this will definitely be lit up. They like lights lighting up then, didn't they? This tape deck's got even more problems, but it's not a complete failure. I've made quite a lot of progress. I'll have to drag it on to another episode. Catch you next time.